Hi, my name is Jun Wei. I'm an applications engineer at Tektronix. And today I'll be showing you how to perform IQ data capture and playback using one of our real-time spectrum analyzer and an arbitrary waveform generator. On the top here we have the RSA518A, which has a 40 MHz of instantaneous bandwidth, a frequency range that goes from 9 kHz to 18 GHz, and can stream and record gapless IQ data. On the bottom we have the 70001B, which can sample up to 50 gig samples per second and has up to 32 gigasamples away from memory. And I'm also using a software called Source Express, which allows me to control this unit remotely from my laptop. And for today's demonstration, I'll be capturing and playing back the signal from this FRS two-way radio. Let's get started.
Let's begin by setting our center frequency to the first channel of the radio. Since the signal is narrowband, we can change the span to 100 kHz. Next, let's open the time overview window. This window shows the amplitude versus time and the length of the acquisition. As I push the radio button, you can see the signal's amplitude go up to about -10 dBm. Next, let's go to the trigger menu and set up a power level trigger. We can set the threshold to -30 dBm. Now when we push the radio button, the RSA will trigger and capture a single acquisition. Notice the acquisition length is too short. I'll increase this length to 1.5 seconds and give myself enough time for a short recording.
Testing.
Now once the acquisition is complete, we can trim down and remove the dead time by dragging the right window pane into the left. We can now save this acquisition, which contains the I and Q data, as a .tiq file. Select Analysis Length Only and Current Acquisition. Now that we have the I and Q file, we can move over to the arbitrary waveform generator. Here is the Source Express software. This software allows you to go into different virtual sessions for all of our A2G models and create waveforms offline for that particular model. At the moment, we are currently connected to the unit via local IP. As you can see, it's currently set to active. Now to load our I and Q data for playback, we go to the Capture Playback tab on the top. Here we can specify a carrier frequency and load the I and Q file. Let's load the TIQ file we saved earlier. And you have the option to change how you want to scale the amplitude and offset of the waveform. To make it interesting, let's change the carrier frequency to channel 2's frequency. Let's go to the compile settings and select compile and assign to the unit's output channel. And click compile. This will take several minutes to compile for this 1 second long playback. We can fast forward and skip to the completion. Once the compile is completed, the waveform is created within a sequence file called signal1. We can modify this sequence to change how the waveform is played. First, let's change the sequence to wait for trigger A. Next, we'll have it play with the waveform 3 times in a loop. And then go back to start once it completes. Now enable the output channel and click the play button on the top. The process will start loading the waveform. Once loading is complete, the unit is ready to play the waveform, and it will wait for the user to click Force Trigger A. Let's change the radio to channel 2 and listen for the playback.
Testing, testing, testing.
As you can see, the playback was successful, but let's verify this on the spectrum analyzer. Using a second radio set to channel 1, you can see the signal come up as I push the talk button. And here's the playback on channel 2.
Testing, testing. Testing. Testing.
Now let's see that again, but with max hold off enabled.
Testing. Testing. Testing.
Next, we can right click and add markers to each of the signal peaks. Here you can see the frequency on channel 1 and 2. Now this concludes one method of capturing INQ data. The next data capture method is available on the RSA 300, 500, and 7100 series. This involves using the recording control panel to record gapless raw A to D data. First, let's go back to the trigger menu and enable power level triggering. Next, click on the second to last icon on the top to go to the recording panel. Here you can configure where you want to save the file and which output format to pick. On this tab, you can configure how to start the recording and how long to record. For this demo, I want to record on trigger and set the recording length to 2 seconds. The status on the bottom shows you how much disk space is needed for the length of recording. Now I can begin recording.
Testing.
After 2 seconds, we now have our captured raw A to D data. To open large recorded files that are up to several hours long, we have a software called DataVu-PC. This software allows you to load your recorded file, convert it to TIQ or SIQD format, and lets you see the spectrum playback. It also has powerful search tools that allow you to go through large datasets of capture and find specific signals of interest. Once we have the file loaded, you can see the spectrum playback. On the bottom, you can see the play time, and notice we have a lot of dead time at the end of the recording. If we go to the time overview menu, we can trim out the dead time in the file. Here is the full signal capture of this file. To trim this file, we can right-click and set new start and stop index markers. On the bottom, you can now see the new start and stop index. You can see we have reduced the dead time in the recording. Now we can click on the top to export this slice of data. To play this back on the arbitrary waveform generator, we want to save this as a TIQ file. Now that it's complete, we can go back to the generator and load the new shortened file. To save time, I have the shortened file compiled and preloaded for playback. And on the right, we can verify our playback again on the spectrum analyzer.
Testing. 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 Testing.
As you can see, this method also works for playback. To conclude this demo, you can use any of our real-time spectrum analyzers and arbitrary waveform generators to perform IQ data capture and playback.
Hope you enjoyed this demo. Thank you for watching.